Cold water, session 1, part 1, water cycle and water treatment. Before we start this module, it's very, very important to note that actually a lot of the stuff that we're going to talk about in this module is also relevant to the hot water module as well. Just like we in processes, a lot of the stuff in processes is going to be relevant to cold and to hot and to heating. A lot of the stuff in this module will also be relevant to us in the future, so make sure you learn it thoroughly. Examples of direct and indirect systems. They're slightly different for cold and hot water systems, and we're going to cover that at a relevant point. We're going to talk about backflow, we're going to talk about water categories, cisterns, valves, taps, showers, commissioning process. All this sort of stuff is almost equally as relevant to hot as it is to cold. So we're going to cover it now and recover it in the next module as well. Okay. So for this particular unit, part of the unit, I want you all to be able to explain what happens at each stage of the water cycle, identify above and below ground water sources, list in order the water treatment process, and describe in detail how the water gets from the treatment plant to our taps. And that would include being able to identify the position of each of the pipes, correctly naming them, and stating the key sizes, the sizes of the pipes, and also the depths they should be buried. Okay, this is also key information. So, water cycle and water treatment. We're going to look at the water cycle, water treatment, and the way water is supplied to our properties in this session. Like I've just said, pay particular attention to the pipe depths, name of the pipes that we're going to describe in the later parts of this session. Okay, I'm going to talk firstly about the water cycle, and then we're going to look through water treatment to delivery. So essentially, the heat from the sun causes water to evaporate. It turns from a liquid to a gas. That would then start to condense. If there'd be like little particles of dust, pollen, whatever in the atmosphere, and water starts to condense around these particles, which can initially start to form clouds, and then these clouds will grow, and then eventually rain will fall, also known as precipitation. So precipitation is when fluid falls out of the sky, rain falls or snow falls out of the sky. Then it hits, in a lot of cases, the ground, and then it would run off the ground back to a water source, be it a river, a stream, or a sea. Interestingly, a large proportion of the water that's classed as runoff actually is groundwater. It actually flows through the ground. And we can access this quite often in aquifers by digging boreholes and stuff, which we'll look at briefly soon. Okay, so yeah, this is the water cycle like we just talked about. So firstly, we have heat from the sun, which causes evaporation. That evaporated water starts to condense and becomes water saturated clouds. Water saturated clouds will eventually the water from the rain, water from the clouds, sorry, will fall as rain, and then will run off back to the sea. Okay, sources of water. So we need to know about above ground sources of water, like lakes, rivers, streams, upland surface water, or reservoirs, and below ground sources, which could be boreholes, which are drilled into the ground to access aquifers, deep wells and shallow wells, again, to access aquifers, and springs. A spring is where a stream kind of comes out of the earth, essentially. Okay. Hard and soft water. We'll very briefly look at what this means. So in simple terms, hard water is alkaline. It generally contains dissolved mineral salts like calcium carbonate or calcium sulfate. When water flows over ground that contains minerals like chalk and limestone, then the water will become hard. Soft water is acidic. It generally has got dissolved gases in it, like carbon dioxide from the atmosphere. And if the more CO2 it dissolves, the more acidic it becomes. So if, for example, it flows over a stone that it can't dissolve, like sandstone. It will dissolve more gases from the air and make it softer. Or if it flows through moorland, quite often sort of some of the byproducts of heather and stuff that grows in the moorland can be quite acidic, and that will make the water more soft, essentially. A good way to remember, I always find, is hard water contains rocks, dissolved salts. Soft water contains dissolved gases. Helps me remember it. So hard is dissolve something hard. Soft water is dissolve something soft, like gas. Okay. So rainwater, actually, all rainwater is naturally soft. It's naturally slightly acidic. So key facts about hard and soft water. Hard water can cause lime scale, depending on whether it's permanently hard or temporary hard water. But we'll look at that in a lot more detail in your principles module. Soft water can corrode pipework, which can lead to pinhole. If you've got an issue with hard water, you can soften it using a water softener. City and Guilds quite often called a water softener a water conditioner. So, water treatment. This is for public supply. All water that comes from our taps has to be treated to make it safe to drink. And the process is as follows. You take water from the water source, which is quite often going to be a reservoir. You put it initially through a screen. You pump it through a screen to take out large particles. And then it's it's mixed actually quite often with something called a flocculant, which causes the bits, any sort of sediment inside it to start to stick together, flock together essentially. And then it's put into a settlement tank, a sedimentation tank, sometimes it's called. And that's just left to settle for a period of time. The particles that start to sort of either float to the top or fall to the bottom are then removed essentially, and that water is pumped on to a filter. It could go through several filters. Sometimes it would go through a sand filter and a carbon filter, sometimes just a couple of different sand filters. And that takes out any further small particles. And finally, it's disinfected. They normally add chlorine. In some cases, they might bubble ozone through it as well, which is like a O3, or it's lots of basically oxygen, to sort of kill anything that might be continuing to live in there. And then it's taken and it's stored, and before it's delivered to the properties. Okay. There's a good video here on water treatment, which you guys can access through the PowerPoint, which is on eZone. Okay, so have a look at that if you've got the time. Okay, but what we're going to look at now
to fresh
delivery. So water comes from the water source, goes through the treatment plant. Once it's been treated, it would then go into what's known as the trunk main. The trunk main is the largest main. That's the main which is coming from the treatment plant, and it would contain a massive amount of water. It'd be really quite big. As the main is split down, it would then be known as the principal main. It's the next step in the process. And finally, just before it goes off to, say for example, an individual street, it would then be known as the local main. Okay. As the water comes off the local main, we have further names for different parts of the pipe. Okay, and we're going to look at this now. Everything before the property boundary is the responsibility of the water supplier. And this pipe would be called the communication pipe. This external stop valve and water meter, in most cases, in most new properties, are going to be fitted right on the boundary. Okay. Everything after that, after the external stop valve, inside the boundary is the responsibility of the homeowner. The pipe from this point often is called the supply pipe, though on occasion you might see it called the service pipe. Okay, so this pipe here, the one that comes from the boundary into the property, sometimes they might call it the service pipe, sometimes they might call it the supply pipe. Everything from the internal stop valve onwards, if it's coming off the mains, should be described as this coming from the supply pipe, but this particular point from the external stop valve to the internal stop valve can sometimes be called supply pipe, can sometimes be called service pipe. Might be worth noting. And another key thing to note, both the communication pipe and the service pipe or supply pipe should both be buried a minimum of 750 mil in terms of depth to protect it from frost, and a maximum of 1,350 mil to ensure that it is still reasonably easily accessible. Okay. So pipe names and positions. So supplier's local main, this comes from the supplier, be a large size, often sort of over 100 mil. It's got lots of connections off it which feed lots of different houses. Connections would be made using something called a ferrule. This allows you to make a live connection to the mains essentially. Communication pipe, like we've talked about, it's the name of the pipe which comes from between the supplier's main and the boundary of the property. Communication pipe, responsibility of the water supplier. Normally it's 25 mil. Normally you use MDPE for this, medium density polyethylene. Okay. The external supply pipe, also known as the service pipe, is the responsibility of the homeowner. It's come onto the homeowner's property by this point. It is their responsibility if there's a leak on the service pipe or supply pipe. Okay. It runs from the boundary into the property, normally 25 mil MDPE, and as it passes into the property, it must go through a sleeve to protect it. Should be buried between 750 mil deep to a maximum of 1350 mil, so it can be maintained easily. As it passes through the foundations, it will be protected, and interestingly, if the property has a solid floor, it should come up at least 750 mil from the external wall to still ensure it's given that frost protection. If it does come up within 750 mil, it still can be okay as long as it's appropriately insulated. Okay. Interesting fact, if you have a suspended floor, like you can see on the left hand side here, one which the air circulates freely underneath, it doesn't really matter which distance you take it up from the external wall, because it's going to be really, really cold under the suspended floor anyway because of the air bricks. It will be as cold under the floor as it is outside. So whenever you take a pipe up through a suspended floor, you must always make sure that it is adequately insulated. Okay. External stopcock and water meter. So the external stopcock and water meter is the one that's outside the property, near the boundary of the property normally. The purpose of the water meter is to measure the volume of water used by the property, and obviously the external stopcock would turn off the supply to the property. Sometimes it would turn off the supply to a number of properties, so you need to be careful if you ever switch off the water here. Okay. Water meters, briefly look at water meters as an example here of an external water meter that would be next to the edge of the property. You also get something called ground breaker water meters, like you can see in the picture here, which is sort of pops up through the ground and breaks the ground more easily for people to read. And as well as internal water meters, which would be installed inside the property. Key fact, to note, for all of these, they must be installed before the first draw, so it measures the entirety of the volume of the water used in the property. Okay. Very briefly, going to look at private supply. Okay, occasionally, very, very occasionally, like one person in every 100 would get the water from something known as a private supply. Generally, this is going to happen in remote rural areas. Might be getting it from a source like a borehole, a spring, or a stream. And essentially, the process is pretty similar at a smaller kind of size level than the public supply. The water is going to be taken, it's going to be filtered initially, and then it's going to be disinfected. Interestingly, quite often the way that they disinfect private supply is actually using light. They use UV light to kill any viruses which might be in the water, rather than chlorine. But in some cases, some private supplies might use chlorine to disinfect the water. Okay, and now it is time for your tasks.